Great. Wonderful. So yeah, so today what I want to talk about then is so no mapping today, at least like dialect mapping, but we're going to be talking about the evolution of the structure of British patents. So really focusing in on how like the discourse structure of these patents has changed over time, about 300 years. This is work with Nick Groom, my colleague at Birmingham. He's actually the one that got the project started, as I was talking to Tony about kind of before we got officially started here. And then I came on and I've been doing more of the sort of quantitative analysis. But today I kind of want to frame this a little bit differently, a bit more broadly about language change and language evolution as well. Oops, sorry. Sorry, I'm having a little, oh, here you go. Oh, okay. Sorry, can you, no, sorry about that. Oh, sorry, I see why. I'm at the very last slide. No, I was just at the very last slide as opposed to the first slide. Okay, great. Sorry about that. Okay, so this is the kind of topic I kind of broadly want to kind of try to tie this research into, and that is, why does the structure of language change over time? I mean, to me, that's one of the sort of most longest standing and fundamental questions in linguistics, right? I mean, it's something that concerns philologists. It's something that concerns corpus linguists, of course, something that concerns sociolinguists and historical linguists, and a lot of people in other fields as well, or in other subfields of linguistics. I think we know actually I think there's actually relatively little agreement on like what drives language change. But I think there is sort of something of a standard view, and it's the view I don't share, and I'd like to kind of argue against. And that standard view is that basically that overall, at least, like maybe not on the individual feature level, but overall, language change is ultimately arbitrary, at least from like a communicative perspective. And what I mean by that is that like, we all know the structure of language changes, but the view would be that like it changes without much or without any real kind of communicative overall value, right? Like it doesn't become, say, better over time. The communicative potential of language remains stable even as it changes. And that's really, I think, a pretty standard view, right? Like it's generally seen that, that function isn't like a major driver of language change, at least function in a really strong sense. So in particular, I think the standard view, or at least the view that's probably shared by most people, like say in sociolinguistics and in that directly study language change, is that, language change comes about for sort of a complex bunch of different reasons. Hard to put your finger exactly on which one matters in any given context. Probably they all kind of do. But like in particular, the process of language learning is seen as driving language change. Like just that language is so complicated and variable that it's, it's difficult to learn. And so we start to get variation. And new variation emerges, and because speakers exploit this variability to express social information, right? And so this is the idea that that we use the fact that language varies, that we can express the same basic information using different forms. We use this information, and that, or we take it variation to then express social information. We can vary our language, still communicating the same basic information, but we can use that to kind of express additional meaning. And I don't doubt both of those things are sort of important, but I do disagree with the view that functional explanations for language change, that is, that language changes to become better suited for communication, broadly speaking, are generally ruled out in mainstream linguistics, and that I think is unfortunate. And I'd like to present an example today which definitely shows you how language changes to become better suited for communication. I also want to kind of tie into this topic of language evolution. I mean, this talk was sort of originally scheduled, or at least a version of it was originally scheduled to be presented at the @EvoLang conference. And so I kind of want to kind of tie that in here too. I think it's really important to say, like, despite what I just said, that a lot of people think that language change is essentially arbitrary. I think everyone agrees that in the history of language, there was non-arbitrary change. And that would be as language first evolved or emerged in our species, that it must have been much structurally simpler and functionally less complex at some point in time in the past. And it must have risen up and become more functionally diverse, more structurally complex over time. I don't think anyone can really disagree with that. But then how do you reconcile these two viewpoints? And I think the general approach is that then language change and language evolution are seen as being separate things, right? So language evolved at some point, and now whether or not it's evolving is sort of up in the air, but how that relates to language change is that they're sort of two separate processes. And that's even after, we factor out the kind of role of biological evolution, like evolution of the brain or of the vocal tract or something like that. And notably, even like evolutionary inspired functional theories of language change, like say Crofts' theory of language change, evolutionary theory of language change, still, although they're functional in a sense that they normally acknowledge that like the actuation of a language change, the actual introduction of a new form is going to be functionally motivated. They see the spread, so actually what's necessary for a change to actually take place, the spread across multiple people, across society, to be kind of a basically social convention around about social meaning and stuff. And then finally, I mean, at the far extreme of these kind of functional theories would be like a teleological explanation. And that means like a theory of language change where you argue that the change takes place because language users, like actual speakers and writers and signers, explicitly change its form to better meet certain functions, like certain communicative functions. And that's especially controversial, and that's, generally dismissed by most researchers of language variation and change, at least in sociolinguistics and historical linguistics. So I would like to try to argue, though, that these teleological explanations do make a lot of sense if they're in fact kind of inevitable in certain contexts, and that really we can see language change and language evolution as being the same basic process. That's what I just said. I think the reason why people haven't really appreciated the importance of a function in language change is that generally studies of language change ignore both text and context. So both the text as a unit of linguistic analysis and the idea that texts occur in different contexts and that these contexts matter. I mean, not just the idea that contexts matter, but like the idea that specific contexts matter. So, generally speaking, studies of language change focusing on individual features or sets of features, but usually individual features, say, of sound change, some grammatical features, but they don't look at features of the text. They don't look at like kind of the discourse structure of a text. So, and the units of analysis are not text. They are probably just the occurrences of the feature. I mean, even in like Crofts' evolutionary theory of language change, it's the utterance, not the text, that is the unit of analysis. And I think when you start, if you think of the utterance as something smaller than a text, or a text composed of utterances, then, you can see how that's sort of limiting. You don't see kind of the effect of people producing text, like broadly speaking, conversations, texts, whatever, like, full communication, full acts of communication, that you maybe miss this a bit. And then similarly, research on language change tends to ignore variation across different communicative contexts. They tend to focus nominally, as in not directly, but nominally on the spoken vernacular accessed via, surveys, interviews, whatever data you can get your hands on. And so the argument I want to make here is that when you consider how texts, not sounds or words, but how texts change and how they change specifically in specific communicative contexts, that functional and even teleological explanations for language change become undeniable, and this difference between language change and language evolution disappears, at least in part. Okay, so those are some kind of broad and fairly controversial ideas. I'm going to zoom in now on this one study that Nick and I have been working on. As I was saying to Tony before we started, it's a little bit cherry picked in a sense. Like it's a very specific change and a specific variety that I think is well suited to showing this. But I'll come back and try to generalize at the end. So what we want to do here was is look to see how the discourse structure of British patents changed over time. This is research that Nick started and that I then got involved in. And the basic idea here is we want to see like not how like the grammar or sounds or something like that changes. We want to see like how the actual way that these texts are, these patent texts are created. A patent, I guess, is quickly, a legal document that establishes somebody's ownership of an idea, I suppose. I mean, I'm not, maybe that's not entirely accurate, but I'll give you some examples here in a second. And so what I want to argue is that change in this context and at this level of analysis, like at the level of discourse, is clearly driven by political and cultural change. and that the evolution or the change of this genre that we're going to see in this register is by no means arbitrary. It's a process of the structure of patents being adapted to the changing communicative context in which they're used. So I'm going to present you, I think, evidence that really shows clearly that this is a functional explanation for these changes. And I'm not trying to argue that nobody has done this before. I cite, a study by, Doug and Bethany's book with Cambridge. I mean, this shows something similar. Okay, so here's the corpus. It contains 277 randomly selected British patents. That's one per year between 1734 and 2011. So it's almost 300 years of data, well, 277 years of data. There is 1739 is missing, and I believe that's just because there were no patents issued that year. I believe we might also have, I'm sure we do. We have data farther back than this actually, but it's a bit more spotty, so it's not included in this structure not to have loads of gaps in the time series. We then actually, Nick mainly, then manually coded each of the patents as a sequence of discursive moves. So this is a move analysis. Basically, this is a kind of a relatively common form of discourse analysis. The idea is to take a text and to segment it into the chunks that achieve different communicative functions. So like, the canonical example is like splitting up a academic article. You have an abstract, you have an introduction, you have a method section, and you can look then, if you do this for a corpus of text, you can then look at variation and patterns in the structure at the discourse level, like above the sentence level structure in these texts. So that's the idea here. I guess it's nice to say that this is like what we call like a long and thin corpus. It's obviously, not that many texts for 300 years, right? I mean, it's one text per year. So that has some limitations, of course. But the great advantage here is that we can cover a lot of time. And obviously this is all hand coded, so it's not like an easy task. We did do inter-rater reliability testing. That's my contribution to this, and it was, pretty high. I don't remember the exact results, but it's not such a hard move analysis. I mean, if you've done move analyses, and I've done move analyses in other contexts, like an online chat, and like, it gets quite complicated, but this is such a sort of, these specific tasks have to get done, or at least, for a given period of time, people think they need to get done. And so you have it quite nicely kind of split up into these, it's quite easy to split up into these moves. And I don't think it's especially controversial. I mean, obviously we could do this a little bit differently, and there was a period where we had more moves and we tried to consolidate them down to give a more kind of parsimonious analysis. But I don't think any of these are particularly controversial. We had no trouble replicating the analysis, and I think if you had slightly different, if we agreed upon slightly different moves here, I don't think the general analysis would change at all. So here they are. That's, I don't know, what is that, like 21 moves or something. And so you can just see what they are. I mean, the order here from A, B, C, D. I mean, so the first move, the first move in the first text in the corpus is a salutation. The second move in that text is a royal grant. So these are just the order in which they appear. That's how these letters were assigned. And they cover a lot of ground. So various sort of technical, or various, I guess I should say, like kind of bureaucratic things like, petitions and witnesses and royal grants and stuff, filing information, and then, various things that are more about the content, like especially like the invention description, letter E. And these change over time. So this is the entire set that we find in the 300 years. I don't believe, I'm almost positive there's not a single year where all of these are seen in one text. So here's what a copy of a British patent looks like. It's from 1789. Maybe I'll just read it here quickly. This is for shoe buckles. So to all to whom these present shall come, I, John Ellen of Pimlico, in the parish of St. George, Hanover Square, in the county of Middlesex, gentlemen, send greetings. Whereas His Most Excellent Majesty King George III, by his letter patent under the Great Seal of Great Britain, bearing date at Westminster the 29th day of August, now last past, did give and grant to me, the said John Ellen, his special license, full power, sole privilege of authority, that I, the said John Ellen, my exers, admors, or assigns, should and lawfully might, during the term of years therein expressed, make use, exercise, and vend throughout that part of Great Britain called England, his dominion of Wales, and the town of 𝗏𝗏𝗏 my invention of an improvement to shoe buckles. Okay, so that's kind of what these things look like. They're not especially long, and here's how we broke this one down. We start off with this thing called a salutation. We then have the royal grant. So this is where he says that the royal grant has been assigned to him. We then have the condition statement, which tells you the conditions on this grant. We have the declaration that there's an invention that takes place. And then on the next page, we have the most important part here, which is the invention description. Okay, and then it's finished off with a witness, another witness, and then this enrollment confirmation. Okay, so you can see a mix here of, you can see these are clearly doing different communicative goals for the patent owner, and that they are, and that they're sort of a mix of the actual content and then these sort of more bureaucratic technical bits that need to be there, or perceived to need to be there. And that's what one of these looks like. Oh, and then, sorry, then there's finally some drawings, okay, at the very end of this. So the idea here then is that we take this patent and we reduce it down to this string of characters, A, B, C, D, E, F, H, G, J, okay? That is the sequence of those moves, right? This sequence here, right, of these moves in this particular patent. So now we can essentially distill this patent, at least from this structure, this discourse move structure, down in this case to a 9-character string. It doesn't just go perfectly in alphabetical order because some changes already happened, right? We've already had, like, earlier G came before H, and now G is coming after H, okay? I's been dropped. Okay, so we can then do this and pull out all the patent move sequences in the 277 patents. So in total of those 277 types, we see, given our system of annotation, 51 different, of those 277 patent tokens, we see 51 different patent types. Each of them is represented by a string of characters, which are kind of, fairly meaningless there on their own. I guess if you can scroll back, you could find them. But, there they are. And you can see in particular here that, this follows something like a kind of a 𝗏𝗵𝗲 distribution with a small number being very common, relatively common, and then quite a few that only occur once or a couple times. So that's the basic first thing we find, right, is that clearly there's a lot of variation here, and clearly some forms are more common than others. So like I said, in particular, over that 277 years, we see 51 unique move sequence types. And here are the first ones. So you can see the first one is A, B, C, D, E, F, G. The second one, you get the insertion of H, and so on, right? And then you get back to but the A, B, C, D, E, F, G comes again in 1742. That holds on for a few years until 1745. It gets replaced by another one. Now, again, like, we really should stress here that there's obviously, like, lots of other patents, at least at some points, there's lots and lots of other patents being used. So this is just one randomly selected one. So it's just a kind of a snapshot. That's not to say this is absolutely what was happening. But in some ways, then the question, and then you can see where it goes, and you can see really by the end, by 2011, it looks nothing like it did back in 1740, right? So it goes from A, B, C, D, E, F, G to 𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏, and you can see there's only one thing that's remaining there, I believe, and that is the E, okay, which is the description of the patent, and so of the actual invention. And so, kind of our question then, the sort of focus question then for this talk is, like, how and why did the discourse structure of British patent shift from A, B, C, D, E, F, G to this 𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏, right, over these 300 years. Okay, so we did this then with sort of 3 stages of data analysis to look into this. The third stage, I think, is probably the most meaningful, but it's maybe the more complicated part to interpret, and we probably have a bit more work to do there still. But let's go through these then each one at a time. So first, we look just at the use of each of the 51 unique move sequence types. So as in, that histogram I just showed you, those 51 specific move sequence types, we looked at them individually, we looked at them together, but we didn't break them down, right? So we ignored how similar the strings were, meaning that, we're just looking at the types. ABC is as close to ABD as it is to XYZ, even though, obviously ABC and ABD are actually pretty close. Okay, so this is what we found. So this is a graph here. It's basically like a kind of a strip chart for each of the types over time. And so what you have on the y-axis there, on the vertical axis, is a list of all the types that we see. So there's 51 rows on this image, and they're ordered by the first appearance. So you see A, B, C, D, E, F, G's first, and then you can see the last one is well, actually the last one is not last, because the very last one in 2011 was actually the third last one seen. But what you can see then is where every time you see a black bar, that means the patent for that date was that type. So you can see that A, B, C, D, E, F, G is the first one. You can see then that A, B, C, D, F, H, G comes up, and then you go back to A, B, C, D, E, F, G for a while. And so I think maybe the first thing just to notice here is just that, like, you know, this is a highly variable register. Things are changing the whole way through, basically. That there are stages that are perceptible, that at many times you'll have multiple forms in competition with each other. I think it's notable that just with only one per year, despite the fact that there's many more than that each year, we do see this, like, you know, a fairly limited number here, and we see them in competition over a short period of time. So you can really see what's happening here is that there's sort of these like competing structures that are up against each other, but you can also see it at points in time really get a wholesale shift. Let's take a look at some of those sort of specific time points. So here's maybe the first big one you can really see. You can really see here that that at 1852, you get a real complete change, as in none of the structures you saw before 1852 show up again after 1852, even though they're all highly variable leading up to that point. What happened here was there was a Patent Act. And if I recall, and I don't remember all this stuff the most well, but if I recall, this Patent Act was really the first big patent act that really started formalizing how these were written, or rather than formalizing how they were written, formalizing the law around how patents would be judged and distributed and received, and that then therefore had some clear knock-ons to the structure of these things. And in particular, if you look across at the left-hand side of the screen at the list there, I know you can't probably see those letters, but I think you can see that at that point, at 1852, they got a lot longer, right? So that's the first big change we see. I'm not saying there isn't change before them, but you can just see how kind of categorical the change is right there. Then we have another Patent Act in 1883, and we can see something similar, right? And what we can kind of see after 1883 is that although a lot of the new, although in some ways those series look quite similar, like you can see they all start with L's and S's and stuff, not with A's and B's, that they get shorter. So in 1883, there's a bit of a streamlining of how patents were being written, I guess in some sense in reaction to the 1852 Patent Act. And then one other Patent Act here, we could try to look at other points on this graph, but I kind of want to move forward here, is the 1977 Patent Act, and you can see a clear change there too. I'll talk a bit more about the kind of details of these 3 points in a second. The main point, though, is that overall we see really near constant change in patent structure, with various forms in competition with each other over really extended periods of time, and we see really that no single form emerges as the standard. You know, I mean, if anything, sorry, jumping back here, and anything has become quite a bit more stable here since the 1977 Patent Act. But you see there still is competition there, and at least 2 different forms really going. And again, this is just one per year. So, you know, probably some more out there as well. And then the other thing we kind of find here is that specific sequences will stay in use for years. You can see that, right? I mean, you can see like some of these sequences are in there for like over 100 years or at least 50 years. But we also see clear stages, and what happens there is that these that new competing discourse structures come in and they completely replace the old ones. And this seems to be mostly precipitated by legal changes. The gradual change and the competition doesn't seem to be as much directly precipitated by legal changes, but these big hard borders do. Okay, so that was the first part of this analysis. The second part we did was we looked at the individual moves. So still not like looking at like the strings against each other fully. We'll do that in stage 3. But the second stage here was to look at individual moves. We just really wanted to see like did the occurrence of the individual, like how did the occurrence of the individual move types change over time? Like regardless of the larger move sequence string in which they occur, like where they're positioned, or which other forms were in there, or how similar that string was to other strings, just really focusing in just on these individual moves. And I think that lets us really see how these like kind of building blocks of these discourse structures come and go. So again, here is a histogram just showing the moves. you know, I mean, it's not very 𝗧𝗵𝗲 actually now, right? It's just sort of like a gradual linear decline. We see that this is percentage. Sorry, this is this graph shows, it probably should be a bit better labeled. It shows percentage of the 277 move types that contain each of those forms. Okay, and so you can see that E, the actual invention descriptions, in 100%, but nothing else is. Okay, so here's another graph, kind of like the last one, like another strip chart here. And now this is the all the moves, excuse me. All of these moves on the left-hand side, labeling the rows. And I really would have been nice of me to have put the more meaningful labels there. Sorry about that. And then we see the timeline. And again, each of those lines just tells us that in that move we saw, in that patent from that year, we saw that move. And so you can see, for example, the very first one includes A, B, C, D, E, F, G. You know, that also happens to be the order in which you see them, but that's not necessarily the case at any other point in this graph. Okay, so what we can see here, I think, is we can see some really clear categorical cuts. I mean, much more categorical in many ways than what we saw when we looked at the whole sequences. And so what we can see here is that although the sequences kind of gradually change, and that is to say, like the order in which these moves are combined, that order seems kind of gradual unless you have this really strong thing that comes in, that no matter what, like you really get pretty sharp starts and stops, broadly speaking, on these moves, or at least to a greater degree than they do in the sequences. I think that makes sense, but it's not necessarily the case. There's really, like I said, there's only one that's in all of them. That's E, the description of the invention. But the one that actually kind of shows a more gradual pattern is the use of figures. I guess maybe O and P do to some extent, but really the one that really shows, you know, not like kind of abrupt turn on and abrupt turn off, is the use of figures. And so you can see, you know, they were fairly rare until well, they're fairly rare up until about 1800. They weren't occurring all at first, and then gradually over time you get more and more figures. And I think we can probably guess why that occurs. It occurs presumably because drawing figures becomes easier over time, and perhaps because the inventions become more complicated and therefore need figures to explain them and to describe them fully. But you know, that's clearly something where some cultural pressure about technology and about the level of both the technology for making figures and the level of technology have changed over time and necessitate a somewhat different structure, or in this case, a different move. We can also see these clear breaks. So again, the real clear break here is 1852. And what you can see here in 1852 was they did lose that one G move, and I don't remember what that is off the top of my head, but like the other ones mostly stay on. It's just that you get a whole bunch of additional moves dumped in to fulfill these like bureaucratic requirements. You can see here's the 1883 one, and you can see then kind of around 1883 for a number, and kind of leading up to 1883 more generally, you're losing moves, including some of those old moves, and that's kind of streamlining, right? Because it got very complicated there for a little bit in the late 19th century, and it gets kind of streamlined here. Well, sort of the mid 19th century, it gets streamlined here, but by the late 18th century. I think it's also notable here to see that, like, you know, some of those things, especially A and B, were already dropping off before the Patent Act came in, and so maybe that's affecting the patent act. So we can see that these decisions made by actual writers of patents might have sort of influenced the legal situation in which these documents were written. That's just a hypothesis. We'd have to look into it in a bit more detail. And then here's the 1977 Patent Act, and you can see again we have certain moves finally dying off right after their consistent usage for like over 200 years. Those actually are the ones that are about witnessing that system changed. And then the stuff at the bottom are a bunch is related to abstracts and sort of more kind of summary information, which is related to the 1977 Patent Act, which if I recall is related to international, making these patents more international, or you know, easy to move around the world. Okay, so then to summarize, I mean, I think what we see here is as opposed to the more gradual change, I mean, it wasn't entirely gradual, right? But as opposed to the more gradual change observed in move sequences, the introduction and then the loss of individual moves is usually much more abrupt, right? And so it's something about the sort of totality of these individual move changes and the order of these moves, how they're used, which is how you end up getting this more gradual pattern when you look at the entire sequence, the entire discourse structure of a text, but the individual moves are actually, at least in this context, in this register, are actually changing very, very abruptly. And like I said, again, in the case of the biggest shifts, you can see quite clearly that these align with legal changes, external cultural changes, if you want to be more general about it. Okay, lastly, we looked at move sequence distances. So far we see some like important shifts, I think, and I don't think, I mean, I think you have to be careful not to overinterpret those graphs, but I think they are kind of straightforward, and or at least they're fairly straightforward descriptions of the data, right? But they don't really tell us the whole story, and I think that's primarily because, I mean, there's obviously probably other things we're missing. I mean, clearly probably a bunch, but I mean, the big kind of obvious limitation with those two analyses I just presented is that they don't let us look at the change in the order of moves, and they don't let us look at kind of how big the magnitude of the changes are, right? So we see that there's changes, but we don't know like how big the change is. We don't know what exactly is changing. You could have a wholesale switch, and that would be just as big as like just the inversion of the order, say, of two moves. Okay, so to look at that, we look at move sequence distances. So we try to measure the distance between these sequences. This is not a task that is unfamiliar to linguists. It's quite common in dialectometry. My co-author on this forthcoming Cambridge book, but it's not coming very quick, but the forthcoming Cambridge book, Martijn Veling, he uses this stuff all the time, and John Narbonne and these dialectometrists use it all the time, string edit distance, to like measure the distance between words in like a dialect atlas, right? Where you have like transcriptions and you want to see how close they are. It's also very common in, say, in genetic studies, right? Where you're trying to compare DNA, right? Which is represented by a string of letters, C, A, N, G, and T. In this case, we have these 21 or whatever it is moves, and we want to see just how similar they are. So we use string edit distance. Basically, it measures the minimum number of changes of edits necessary to convert one string into another. So, and these changes can be insertions, deletions, substitutions. Whoops, sorry. There's various flavors of string edit distance. This is quite a simple one, but the idea here is that we can just use this to make a more holistic measure of change that does take into consideration the order of these moves. So let's say we want to see like what's the string edit distance between these two strings, SLMUTLJEK and SMTULJEK. And so a question of this, I mean, the way we answer this essentially is we say, well, how many edits, how many insertions, deletions, or substitutions do you need to make to the first string to derive the second string? And there's often like lots of ways of doing this, but they kind of end up the same, at least as far as I know, at least in these examples. I think there might be some issues here with the length, but I mean, or maybe we would like to control for length somehow, but I think maybe length is part of it. Anyway, this is quite simple. So first you would delete the L, then you would delete the U, and then you would insert a U in another spot. And you could do this in different ways, but you end up with a string edit distance of 3. Okay, so the distance between those two is 3, and we can do this between any two pair of moves in our data set, move sequences in our data set. So that's what we did. First, what we did, we just wanted to look at the overall similarity of move sequences over time. So we calculated the string edit distance between move sequences for adjacent years. So for, like we took, 1800 and we compared it to 1801. Took 1801 compared to 1802. Okay, there's obviously some kind of limitations there, especially because we just have a single move per year. But that was our first shot at it. I think it makes sense, and it does give us a picture, as long as we kind of remember that we have a very thin corpus here, like as we've said. And then we can plot the cumulative amount of change over time based on these edit distances. In fact, we can plot the amount of change over time based on these edit distances. I'll show you a few different ways of doing that. The last one is a cumulative plot. So here's just the edit distance for each year to the next year. Okay, and you don't see so much here. You can definitely see that there are some moments of where the edit distance becomes bigger and such. So for example, you can see the 1852 where you have a real jump But interestingly, I think you can kind of see it was getting less diverse, right? Or there was less distance between these strings before. You see a kind of a downward trend there. And then you can also see that in sort of the first half of the 20th century that it was very variable, okay? This might be a nicer way of seeing this. So this is just like a smoothed out version of that graph. And so you can really see, you know, in particular that the variability really shot up like in a more consistent and a more long-term way, let's say, around 1900, right? And you can also see that it's been falling off quite steadily since the 1950s, probably at least in part due to kind of more internationalization of this stuff. Okay, so that's one way of seeing it. I don't think that's the most kind of meaningful way. A better way, I think, is using this cumulative approach. So this is a way that I think makes a lot of sense. Basically, it's the same data, but instead of like showing each one as a bar, you add them up, sort of. So you make a graph where the distance between the first dot in 17 whatever, and the second one is just the distance between those two. But then you put the next one that amount of distance again and again. Sorry, that's not a great explanation. Let me just show you. Okay, so here's the graph. So basically, what's happening here is for every point here, we then map how much distance is there between the pattern for that year and the pattern for the next year. And we do this over and over again. So each year that increases a bit, right? Because every year it could flatline at points if there was no change, but as long as there's some kind of change, it goes up. The amount it goes up year to year depends on just how different it was, right? How distant they were. So the more edits it takes, the sharper the slope, okay? So that's the basic idea here on this graph. The sharper the slope, the more it's changing. And, you know, if you get a bunch of years in a row with really sharp changes, then you get this extended period of really sharp change. The flatter the line is, the less it's changing. So it's changing a bit, but maybe it's just, you know, one move dropping out or two moves inverting, okay? So we can look again at some kind of time points here. Here's the 1852 Patent Act. We can see two things there. One, we can see that it was kind of flattening off, right? Like the change was going pretty steady until, I don't know, about 1840 or something. And then it started started really becoming pretty consistent. And it was at that point, coincidentally or not, who knows, right? I mean, it's hard to tell. It might be something to look into. We then have the Patent Act, and it causes a brief, pretty good chunk of change compared to what was happening before that. It then kind of stables down and gets a bit more stable again. We then have this area here. So this is where it really gets steep, right? Like we get really big change here quickly, or at least very big change in you get much bigger distances or dissimilarities between the patents in this period from 1920 to 1940. I don't quite know what's going on there. I mean, it does very much line up with the interwar period. I don't know if that's relevant. But we can see what's happening here. So we're just jumping back to that old one where we're looking at the actual full sequences. And what you can see is in this little period, what you have is you have these two forms that are in competition with each other, right? So you have two different forms, and actually the first one wins out. But I think what's notable here is that these forms are quite different, right? The first one, the one that wins out, is quite short, and the one that loses out that's in competition is quite long. So we actually have a competition here between these two forms. This creates this really sharp rise. Right, so that's what we find, right? Like we find that this is what's happening. We have this competition between these two specific forms, which are very, very similar, okay? The big difference here is that the first form the second form is longer and has this additional chunk, this OM-DPF inside of it, which notably, much of that is repeated later on. So the M and the D and the F all occur after as well. So it's a bit repetitive, and you can see that the shorter form wins out over time. Okay, so just to summarize kind of where we're at, like, I think what we see is there's a lot of variability, but the degree of variability is relatively unstable. So it's not just like a consistent slope, right? It moves, it gets, sometimes it gets much more stable, other times it really speeds up, okay? So it doesn't seem to just follow some kind of general trend. And to me, at least, I think what that suggests, I'm not sure if this is direct evidence, but it really suggests at least that many external factors are at play here. And then, sorry, I cut that off. I come back to that point later. So it seems like we have many different factors in play. It also seems like in general, like it appears like a really big jump in variability. So like when you really get a sharp change, a really sharp slope on that last graph, is often followed within a decade or so by a fairly big fall, meaning that, you know, it really flattens out, right? So the variability drops, so you get a flatter curve. And that suggests that although the structure is always in flux, big changes, one, they come in bursts, and two, that things settle down a bit after the big change, as sort of things settle down, literally. And then in terms of how these patent structures change, I think what these results suggest is that patent structure change is a continuous and often gradual process. I mean, generally it's kind of continuous. We have change the whole way through, but that gradual change is punctuated by these really quick bursts of change at certain points, which seem to be around big legal changes. So really kind of major changes in the context in which this language is being used. And then things calm down a bit. And notably, you know, we're not talking so much about this today, but like notably this result cannot be explained based on, I guess, kind of two of the main competitors for sort of general evolutionary theories, phyletic gradualism or punctuated equilibrium, which is that, you know, gradualism is that, you know, evolution in general, like in species, for example, is gradual. Punctuated equilibrium is that it kind of it's in equilibrium, it's basically stable, and then you get something happens that will cause sudden changes. You know, in this case, we see both, right? So we see, you know, we get these punctuated moments of change, which are caused by external forces to the environment, in this case, to the communicative context that caused the change, legal changes, let's say, or maybe even bigger geopolitical changes. And then you also get this gradual change over time, which I think is more just, I think you'd expect that even without these kind of big external factors. These are things that are just authors of these patent holders and lawyers, etc., patent lawyers trying to you know, really get the format down and really fit the format to the particular invention they're trying to describe and claim a patent on. So overall, I think what we can see from a kind of an evolutionary standpoint is that we see a bit of both, and there's a term for this, it's called punctuated gradualism, and so I think that's an interesting result. It's a result that Nick could also talk more about. Finally, in addition to comparing adjacent ears, we also compared the string edit distances between all pairs of 277 moves. So we threw out time, right? And we just did an analysis just based on the distance between every pair of moves. So you have 277 moves, and for all 277 moves, you measure the distance between the other 277 move sequences. Sorry, so we have 277 move sequences. We measure the distance between each one of those by computing the string edit distance, and that then produces a distance matrix. So, you know, kind of like a you know, kind of like in an old road atlas where it tells you how far it is between every city in Brazil or England. This tells you what's the discourse distance between all of these 277 texts, and then we take that and we reduce it down to a two-dimensional plot using multi-dimensional scaling. This isn't so different from factor analysis as probably many people here are more familiar with, but multidimensional scaling works off a distance matrix, so that's why we use it. And this then lets us look at the kind of overall similarity between discourse structures across all texts, ignoring date, although we'll throw date back in here in a second. So here's the structure. I've just dropped the axes here because they're sort of arbitrary, don't really matter. And what you can see here is three pretty clear clusters, right? So you get the one cluster in blue. Those are especially old. You can kind of see that if you look at the dates, although there's certainly some overlapping because these structures repeat. In green, over the other side, you get stuff in the middle, and then the later ones are in yellow. We can also plot these, so we can plot when these occur on a timeline like this. So I think quite interestingly, we can see that we get these really three clear stages here, these three clear clusters here from the multidimensional scaling. The first one happens to be totally temporally contiguous, right? It just runs from the beginning of our data to 1852, unsurprisingly, right? Then in 1852, you get this other form that pops up, and it's essentially, you know, relative to the others, fairly absolute. I mean, look, there's lots of different subtypes of strings in any one of these blue, green, or yellow bars. It's just that they're more similar to each other than they are to the rest. And then 1883, well, not actually in 1883, but like a bit ahead of 1883, you get the Patent Act. And so it seems like maybe there we're seeing like kind of a over time reaction. We also can see this kind of, like I said before, we can see it quite clearly here that between 1900 and 1950, 1940, or let's say 1910 and 1940 or so, there was this competition between these two approaches, with the yellow one winning out eventually. Okay, so just a big summary of the entire study. I have a couple minutes here. So one, the discourse structure of British patents have been in a constant state of change. I guess it's sort of repetitive at this point, but with several different forms in competition at any given time. I guess it goes maybe just without saying, I mean, I probably should be stressed that these forms are not arbitrary, right? Like the order of these things is not arbitrary. The constituents themselves are not arbitrary. These are all doing really specific things, and people clearly spent time writing patents really carefully, right? Like, we might compose an utterance and not think about it. We certainly produce speech sounds all the time and don't really give them second thoughts. But, when we start writing texts, we really think about them. And I think, so I think that's what's happening here. We also see that the rise and fall of individual moves is generally quite abrupt, but overall the change is fairly gradual. And that's maybe reflecting a need just to maintain coherence over time, right? Like you don't want to do anything too original unless you are demanded to do that, because you want this to be processed quickly. You want it to be to establish your patent accurately or definitively. But there are these bursts of change which generally coincide with legal shifts. Those are what produce these three stages here we see. And what we can also see here, I think also, so not only do we see like, in general, these becoming more suited to the laws that define patents, but we also see them just becoming more efficient over time. Like we can see these getting shorter and more streamlined over time. And I think we see kind of multiple different factors here. There's certainly others too, right? But multiple different factors here driving it, both these legal changes and just a general kind of communicative need to make things efficient in this context. So thank you very much. I mean, I have a couple more slides. I have one more slide to wrap up. But for more on the specific study, please see this paper by Nick and I. This was in a recent Benjamin's book. You can see there we went from 1711 to 1860. So this is actually goes back further than this corpus. It gets a bit choppy down there, which is why we dropped it out for the kind of more quantitative analysis, and we stop in 1860. And then just to wrap up here, lastly, I just want to kind of come back to those general points I was making. So what I think this study also shows, right, I think really clearly, and I'm not trying to say this is like an original finding. I mean, I think, if you go read by Doug and Bethany's book from 2016, Cambridge University Press, on like academic writing evolution, you see the exact same thing. But I think a lot of this research is kind of outside the mainstream of sociolinguistics, and it's not really in language change studies, and it's not really studies that can, I don't think the results of this study or the results of that study or various other ones that have been done in the sort of more register analysis tradition can be easily explained within sort of these traditional paradigms. So just to wrap up then, I think what we see here is that we can really see here that language change is driven directly by language users, writers in this case, right, patent writers, reacting to the changing communicative context in which they use language. That includes both the legal context, that includes the context of technology more broadly, right? Like these get more complicated as we go on because technology is more complicated. And that can only really be appreciated, or that can be appreciated here because we're looking at the structure of texts, not of like speech sounds or words, but of texts, right? Which are clearly something that we do write quite consciously. It's a big investment of time. Or even like a conversation, right? Like these are big investments of time. These are really complicated things, and across real context. So we can really see, since we're in a real context here, we can see how that context actually affects language change. And I think in particular, what we can see here is that this is actually teleological, which is like a real taboo word in historical linguistics. But we can see here that, I guess we don't see it directly, but I think there's no doubt that language users are actively changing language to better meet their communicative needs, and that that's driving language change, at least at this level. Like I said, we can see this in other registers as well. But then lastly, what I want to make is kind of this argument is that I believe that these functionally motivated adaptations of text broadly defined, including conversations, including anything, right? But bigger than the utterance, these full communicative events, to meet the real world communicative needs of language users may well explain language variation and change more generally. And providing non-arbitrary explanations for language change across all levels of linguistic analysis. Look, they're not going to be as easy to see. If you see a sound change, it's harder to try to come up with some functional explanation for why that sound change happens. It's not easy like it is here, but that doesn't mean it's impossible. And it doesn't mean that actually, if you zoom out to the level of text and you zoom out and start kind of about culture and how these things drive language change, that there aren't explanations there. They might be at first quite obscure and quite convoluted, but that doesn't mean they're not there. And I actually think probably that it's the construction of text that is driving things all the way down on linguistic levels. It gets more and more opaque as you go, but you could see how a massive change in the lexical items that are used in a given context would would really change, like, say, the distribution of vowels in that context, and how that might actually then drive something in a kind of an indirect way. And then finally, I just want to say that, like, I think this explanation actually applies equally well to modern language change and language evolution, that we can see both as basically people trying to use language in a wider and a more complex and a more efficient across different contexts. And I think the way to think about this is we see texts as the organisms, right? Just like evolution, we see texts here as organisms, not utterances, not speakers, not features, but texts. And we see then communicative contexts, the specific communicative contexts, you know, the registers in which texts are being used, or the registers that emerge as the environments in which these are adapting and competing. Thank you very much.